So Unit 1, Lesson 4, Solving Linear Systems by Method of Substitution.
Have you ever done a Mad Lib when you were a kid? This is when you have a list of parts that you have to create. So, for example, you have to give a number of random verbs and adjectives, and then at the end, you substitute it back into a story, and it turns out to be very funny because things are out of context. Let's try one together right now. I'm going to give you a moment. Please fill out this table here, and I'll fill it out too. Then we'll get to see where we're substituting this into and read our funny story together. So for noun, I will pick, say, truck, a proper noun. Mr. President, feeling, sad, a verb, jump, a color, red, animal, plural. I have cats, and body part, head. Okay, so then we flip to the next page, and then we have the Valentine's Mad Lib revealed. When we read it, we're going to take all of these words and put it in where they tell us to insert it. So this part, I would have, be my truck. Mr. President makes my world sad. I always say I jump you. I love red cats too. You make my head flutter. It's silly, and that's the point of it. A lot of kids will have fun laughing at this because it is silly.
So, method 2, solving by substitution. How do we do it? We are going to rearrange one equation, or to be y is equal to something, or x is equal to something, and then substitute it into the other equation. Now remember what we just did with the Mad Lib? We said pick any color and substitute it in. Pick any adjective or pick any verb, substitute it into the poem. We're doing this with math now. And the way we can substitute it in is we rearrange one of the equations so that it is expressed as y is equal to blah, 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 or x is equal to blah, blah, blah.
Let's take a look at this example for us to solve. We're going to solve this graphically and by substitution. So first of all, when we're solving graphically, we need to look for the y-intercept and the slope. So the first equation, we're going to start at -2, and we're going to rise by 5 and run by 1. So 1, 2, 3, 4, 5, run by 1, and up by 5 again, and run by 1. Okay, we have enough dots here for us to create our line. Our second equation, because it's in the standard form right now, I'm going to rearrange it. So 2x plus y is equal to 5. When I rearrange it, I have y is equal to negative 2x plus 5. So we're going to start at positive 5, and our slope being negative 2, we're going to go down 1 and to the right by 1. Down 1, across by 1, and keep going with the pattern. Let's extend this line, and we have a point of intersection. So our solution is where the lines intersect, and they intersect at 1, 3. Now, I know that when I solve this by substitution, I should have exactly the same answer. Let's do it by substitution here and check if this is what we get. Now, if we look at equation 1, we already have it in the form of y is equal to something. In this case, 5x minus 2. Now, everywhere we see the y term in the second equation, we're going to substitute it in. So we're going to substitute 5x minus 2. Okay, so our second equation, 2x plus y, but instead of y, I am inserting 5x minus 2. So this came in place of the y. Let's continue to simplify and to solve for x. So 2x plus 5y, plus 5x minus 2 is equal to 5. Collect our like terms. I have 7x is equal to 5 plus 2. So continuing on, 7x is equal to positive 7, and so x is equal to positive 1. We're going to substitute x is equal to 1 back into an original equation now. I'm going to use equation 1. So y is equal to 5 times 1 minus 2. We have y is equal to 3. Now, what that tells us is we now have a solution. Our solution is given as an xy coordinate. So we know that x is 1, y is 3. So we have the coordinate of 1, 3. We have exactly the same solution, but done two different ways. Let's do another example using substitution. Now, sometimes our equations are given in standard form, and when they're given in standard form, we need to decide on an equation to rearrange so that I have just x is equal to something or y is equal to something. The second equation here looks like it's an easier equation to deal with. So I'm going to rearrange equation 2. I'm going to call it 2a because it's the same thing as equation 2, but just rearranged. I could say x is equal to negative 2 plus y. I've rearranged the subtract y and made it a plus y on the other side. Now, we're going to substitute equation 2a into equation 1. So equation 1, 3 times x, and we know that x is negative 2 plus y, minus 2y is equal to negative 5. So we got this bracket section from here. We know that this is equal to x, so we inserted it where we see the x. Now we can continue to simplify. So negative 6 plus 3y minus 2y is equal to negative 5. 1y is equal to negative 5 plus 6, and we have y is equal to positive 1. Right, we have the first answer. Now we're going to take our value of y is equal to 2 and substitute it into an original equation. Substitute y is equal to 1 into an original equation. I'll pick the second one just because it looks easier. X minus 1 is equal to negative 2. Let's rearrange it. X is equal to negative 2 plus 1. X is equal to negative 1. We have our x value, we have our y value, and so we have a solution now. The solution is given as an xy coordinate of negative 1 and positive 1. Just a hint, we're always expressing this in alphabetical order, so x comes before the y. Slide number 5. Let's solve again by substitution. And it's okay to have a fraction answer. Okay, I'm going to choose to rearrange equation 1 because in equation 1, I already have y that has a coefficient of 1, so I don't have to do a whole lot of rearranging. Let's call that equation 1a. So equation 1a is equal to y is equal to negative 5 minus 3x. We're going to substitute this into equation b now, or equation 2, I mean. Equation 2, 4x plus 5 times negative 5 minus 3x is equal to 18. Once again, my y value here, the whole thing is inserted into y of the second equation. Let's simplify. 4x minus 25 minus 15x is equal to 18. Collect our like terms. Negative 11x is equal to 18 plus 25. So negative 11x is equal to 43, and we have the fraction of x is equal to negative 43 over 11 as our x. So, like I said, it's okay for us to have a fraction. we need to substitute it back in. And with a fraction, it makes it a little bit trickier. So we're going to substitute, let's use equation 1. 3 times negative 43 over 11 plus y is equal to negative 5. Let's simplify as much as we can. Negative 129 over 11 plus y is equal to negative 5. So y is equal to negative 5 plus 129 over 11. Let's use a calculator to solve these fractions. Negative 5 plus 129 over 11, it's given us a decimal number, but we can hit the button at the end to convert it into a decimal. And that gives us y is equal to 74 over 11. Okay, so our solution in this case, we have an x value of 43 over 11 and a y value of 74 over 11. One more example. I want you to solve this using substitution, and then we're going to do a formal check. Just a reminder, a formal check means that we need to know if the solution is going to show that the left side is equal to the right side in both equations. Nice thing here, the first equation is already rearranged, so we're going to just substitute the first equation into equation 2. 5x plus 3x minus 8 is equal to 8. Let's collect our like terms. 5x plus 3x is equal to 8 plus 8. 8x is equal to 16, and x is equal to 16 divided by 8, where x is equal to 2. Now let's substitute this back into one of the original equations. In this case, I'm going to choose 1 because 1 is already rearranged. So y is equal to 3 times 2 minus 8, and 6 minus 8 is equal to negative 2. Our solution here, we have xy is equal to 2 and negative 2. So for us to do a formal check, we need to check that for the solution, y is equal to 2 negative 2 will make both equations have left side equal to the right side when we substitute this in. So equation 1, our left side is equal to y. Y is equal to negative 2. The right side, we have 3x minus 8. So when we substitute it in, 3 times 2 minus 8, and that gives us 6 minus 8. 6 minus 8 is equal to negative 2. Now we've shown that left side is equal to the right side when the solution is 2 negative 2. Now let's try equation 2. Left side is equal to 5x plus y. So 5 times 2 minus 2. That equals 10 minus 2. And we have Left side equals 8. Let's try the right side now. Right side is equal to 8. Hey, left side equals the right side in equation 2 when we use the solution to -2. So our conclusion, since right side is equal to left side in both equations for the point 2, -2, we know that our answer is correct. Okay, slide number 7, 8, and 9. I would like you to pause this video and try these questions on your own. Okay, so taking up the answers, hopefully you've tried it on your own. I've written out the solution and I will let you go through it on your own. This is slide number 8 and slide number 9. Now let's do a word problem. We have G Pool Repair charges $50 for a service call plus $40 per hour for labor. Oasis Pool and Spas charges $30 for a service call plus $45 per hour for labor. Write an equation to model the cost of the service and remember to define your variables. I'm going to say let C be the cost of service. I'm going to say let X be the number of hours worked. Just a hint, X is always going to be whatever the rate is, the rate per hour. So it is X is the number of hours. So let's talk about G Pool repairs. C is equal to $40 times X plus a flat rate of 50. Next one, Oasis repairs. We have C is equal to $45 an hour plus 30 as the base cost. Now, since both of these are already equal to C, we can easily solve by substitution by making the two equations equal to each other. So I want to know when they charge the same amount. Let's make them equal. So 40x plus 50 is equal to 45x plus 30. Let's rearrange the equation. 40x minus 45x is equal to 30 minus 50. Negative 5x is equal to negative 20, and x is equal to 4. So we know that at 4 hours, these companies are going to charge the same. But what's the price that they're charging? So the cost is 40 times x plus 50. So I'm going to have 40 times 4 plus 50. And we simplify that to 160 plus 50. And C is equal to 210. So since this is a word problem, we're going to give it a word answer. The two companies will both charge $210 when there is 4 hours of repairs needed.